As we go on to topic 5 of chapter 1, giving you a little bit of background for what we're doing here. In the earlier algebra course, we would go into graphing in a big way. Here we're only touching on it a little, but you'll need this background for your test on chapter or module 1. Now here we see an equation in two variables, x and y. This is called standard form of the linear equation in two variables. And one of the ways to be able to graph it is to make a special t-chart where we put a 0 for the x there and a 0 for the y there. And if we use this equation, we're going to solve for these values. If x is a 0, this is a 0, then y is going to equal -8. Now if y is a 0, right over here, then x is going to equal -8. So we have, in a sense, two ordered pairs that we can then plot on a graph. So -8 is about there, and let's say -8 is about there. So we take our line and we sketch that line in on our graph. It'll look something like so. I'm off a little bit, but this is just to illustrate what's going on. So this equation is actually this graph on a rectangular coordinate plane. Now the other equation is in the form of y equals mx plus b. That's this one where we solve for the letter y. Now I'm going to put three values for our x and find the corresponding y values. So if x is a -1, this becomes a -2 plus 1. This is a -1. If x is a 0, this x is a 0, 2 times 0 is 0, then this is going to be a +1. And if x is 1, 2 times 1 is 2, plus 1 is 3. So I now have three ordered pairs that I'm going to put on this line. Now this isn't a graph, so it doesn't help us too much, but this is just to illustrate sort of what's going on. Now -1 is about there. 0, 1 is about there. And 1, 3, go over 1, up 3, is about there. And again, I'm just sketching this. So now I take my line and I draw it through here. Now an interesting thing occurs, that at this point right here, the ordered pair of this point of intersection is an ordered pair that will make the red graph, which is this first one, this equation, and this second graph, which is the kind of purplish equation, have the same ordered pair as a solution that would make those graphs true. So we have said, in this case, found this solution through graphing. And had I made it to scale, you would see it'd be approximately a -3 and -5 where they intersect. Now if I put those values in here, a -3 plus a -5, that makes this true. And if y is a -5 here, then 2 times the -3 is a -6 plus 1. A -5 equals a -5. So this happens to be the ordered pair that's a solution for both equations. Now in this method we made a graph of them. But there is an algebraic way of solving these. And that's what we're going to look at here. One method will be the substitution method. And the other method would be the elimination method. And we're going to go over both of these and show you the technique for doing so. Now it's going to be critical that you take notes, and this is your model of how to solve these. And that's what we're doing in our lecture class. Now I have drawn these others to indicate that in some cases, if you were to draw a line, and this would be the first equation, let's say, and you draw another line, and this is the second equation, here the lines are parallel. So would there ever be a point of intersection? And the answer for this is no. There would be no solution here because the lines are parallel. Now, algebraically, what would that look like? Well, I'll give you a hint of that as we go on. Then in the last scenario, we might have a line that we draw. I didn't draw that one very straight. Let's try to do a straight one for our second line. And we draw the second equation, and lo and behold, it's right on top of the first equation. So we know that in a graph like this, there is an infinite number of points along the line, which is the graph. Now, if the graphs are the same, how many answers would you have? How many solutions? Well, since the equations are the same, one set of solutions would be the same set as the other. And since there is an infinite number of points, we say if the graphs are the same, there's an infinite number of solutions. Now, in this particular lesson, they're saying we have to write in set builder notation the answer to the set, and if there's no solution we have to state this, and if we get a single element as a solution we have to do this as well. So I will be showing you all of those things as we go on. This is background to what is going on. And hopefully by seeing it, this will be helpful for you. So as we look at these equations, we're wondering what strategy should we use to solve this system of equations by algebra. Well, the key here is we've solved for one of the letters, y. We're saying y equals this. So if we take this value for y and substitute it in the other equation, it will look like this. X, which is this x. Now this y, we're going to put this value here. And then we're going to write this -8 here. We now have an equation in just one letter, x. So we solve that, group like terms, 3x, transpose the +1, this side becomes a -1, so that's -9, and we divide both sides by 3, x equals, need to be careful of the signs, a -3. So we now have one member of our ordered pair, the -3. Now that we know that x is a -3, we could use this equation. Y equals 2 times a -3 plus 1. So this is going to be a -6 plus 1. Y equals a -5. And if you noticed, in our previous slide, we had shown that it would be approximately this. We couldn't tell. But now, algebraically, we prove this to be true. Now, here's a case where we have y equals this and y equals that. So in a sense, we have y equals y. So we can just equate these to each other. So this would be 3x plus 5 equals a -2x plus 1. And we're using a form of substitution here. So we're going to transpose the -2x to this side where it becomes 5x. Transpose the +5 to this side where it becomes a -5, which will give us a -4. We divide both sides by 5. We get x equals a -4/5. So one of our ordered pair members is a -4/5. Now that would be hard to pick out on a graph, but algebraically we get exact answers. Now, for this next one, we can use either of the equations to find out what y is as we substitute the x. So this is y equals 3 times a -4/5 plus 5. So this then becomes a -12/5. Negative times a positive gives you a negative. 3 times 4 is -12 over 5. Now in order to add these, I have to convert that 5 to something with a denominator of 5. So I just multiply both by 5 and I get 25 over 5. So this was 5 over 1. Multiply the 1 by 5, multiply the 5 by 1. 25/5 is 5. But now it allows me to do the subtraction, and this will equal a positive 13/5. So this ends up as a 13/5. Again, this would be very difficult to graph, but algebraically gives a very good, precise answer. And if you check down below, that's what we have. Okay, you should have all of this in your notes. Now in letter C, we're going to take a careful look because there our y is equal to this. So the strategy is we write out the second equation where the y is. We're going to carefully substitute this in, and let's set it up. So once again, we're going to take this value of y, which is this, and in the other equation, substitute it for the y. Now we clear parentheses. Now notice, interestingly, the x's cancel out, and we're left with the statement 24 equals 24. Now, algebraically, when something like this happens, this is the case where actually the equations were the same, and one line is on top of the other. So what did we say the number of solutions were for this? And we said there was an infinite number of solutions. But we are to give this answer in what we call set builder notation, in which we use a brace. We say our ordered pair x comma y, and then we use this vertical line is such that, and then we just write out one of the equations. 4x minus 2y equals 24. Now, theoretically, you could have used the other equation. In MATLAB, they'll give you three choices: an A, a B, and a C. You have to put a dot in there. This will be an ordered pair. This will be a no solution. And this will be something like that. Either of the two equations, set builder notation. So through these three examples in which we used substitution, the pattern was if you have one letter equals something, you take that, replace it where that letter is, so you then end up with an equation with only one kind of letter that you solve. If you get a true statement after the variables eliminate, then these are the same lines. And let's just show you the other one here. We'll see it as we go down below. But suppose this ended up as, let's say, 5 equals 24. Is that a true statement? And the answer is no. In that case, the lines would have been parallel, again, when you get not a true statement, and they would be no solution. Okay, we're going to go on to do some more. Now in letter D and E, we're going to do this as classwork. I'll help you set it up a little bit, and then we want you to do it. And then I'll come back and show you. So here we're going to solve for one of the letters. Let's solve for y. Just transposing the x to the other side as a negative x minus 3. So now we're going to put this where the y is, right there. And see what you get. And get your ordered pair. And here we're just going to solve for the x. X equals, we're going to transpose the negative 3y on this side. It becomes a positive 3y. And now we're going to take this and put it where the x is. That's what we're saying. Okay, so take a few moments and work these out as classwork. So when I substitute this value for y in this other equation, I then clear parentheses, group like terms, and these just cancel out. So I have a negative 12 equals 5. Is that a true statement? No. So there's no solution for this one. All right, let's go on to this one. So here we're going to put the 3y where the x is. 15y plus 2y equals a negative 17. 17y equals negative 17. Y equals a negative 1. So there's our first member. And then we can use either equation, but we'll use this one. If we put in a -1 there, that makes this a +3. So x plus 3 equals 0. Transpose +3 and you get a -3. And there's our ordered pair for letter E. Now, letter F, I'd like to do that with you together. So again, wherever there's room over on the left side, we're going to write these out. X over 2 plus y over 3 equals a -1. And write it on the edge of the page this way. And then we have 2x over 5 plus y over 5 equals 2. And always double check that you copied it correctly, because I've taken some tests in MATLAB here where I've just copied it incorrectly. It's going too fast. So again, we want to get rid of the fractions, and this will help us with our little study of equations too. So here our common denominator is 6. So we're going to multiply every term by 6. Here our common denominator, there's only the one, is 5. So we're going to multiply every term by 5. Now here the 2 cancels out and we end up with a 3. Here the 3 cancels out and we end up with a 2. Here nothing cancels out. So we rewrite this equation now. This is going to be 3x plus 2y equals a -6. Now this one, the 5's cancel out, and we get 2y, or I should say 2x, plus y equals 10. So the key in this one is to get rid of the fractions. So now we see we have a y. So here we're going to solve for y by bringing over our 2x, which becomes a -2x plus 10. Now this will be our value that we're going to substitute into the other equation. So now let's do that in class and see what we get. So substituting what we have in the other equation, getting rid of our parentheses, combining like terms, we have a -x, transposing that, a -26, x equals 26, which is one of our members. Then taking this 26, putting it into one of the other equations, it's this one here, we get 2 times 26, 52. Transpose that, we get a -52 plus 10. Y is a -42. And that's what our book has. Now again, just this one example took a lot of time. On your Chapter 1 test, I think there's only 14 or so questions. So you may get one like this, and it'll take time, but you want a strategy built on solving equations with fractions, getting rid of the fractions, solving for the letter y, substituting this value into the other equation, and then carefully working it out. Now there's plenty of places to make a mistake, but again, slow and steady, going back and checking your work. Now if this were on the final exam and you had everything right, except this, you ended up, let's say, positive instead of negative, I could give you lots of partial credit for this because you had clearly shown the work. All right, let's go on to part 2. Now in part A we used substitution. Here there is a protocol when we're going to use elimination, which is just another method algebraically to solve what would be that point of intersection if there was one, or if there is the same equation, or if there's no solution. Step 1 is to set them up in standard form. We said standard form was ax plus by equals c. So these are in standard form. The next thing you do is look at them and see if by drawing a line under them and adding them up, one of the letters would cancel out. And the y's cancel out here. So we end up with 4x equals 8 when we add these up. Divide both sides by 4, x equals 2. If x equals 2, what is your other ordered pair member? Well, you can take the 2 and put it here. 2 plus y equals 13. You're going to subtract 2 from both sides, or transpose it, and you get y equals 11. Oh, that's a nice way to do it too. This was an easy one because just by putting a line, they are in standard form, we just add them up, it eliminates one of the letters. And again, in studying them, it's in standard form. Just draw the line. These will cancel out. So we get 13x equals 13. Divide both sides by 13, x equals 1. So we can use either equation. Let's use this one here. X is 1, so this is going to be 5 minus 2y equals 7. And I always like to do this so we know we have one member. Now, we could do it a couple of ways. Transpose the y to get it positive, or just do it this way. Transpose the 5 to the other side. That becomes 2y equals, on this side it's a negative 5, so this is a 2. And divide now both sides by a negative 2. Let me just show you that. Negative 2. Negative 2. This is a negative 1. Now again, if you put these values into both equations, and on a test I would do that to see that they end up as true statements. That's a check to whether or not this is in fact an ordered pair that's going to be a solution for both of them. Now, for letter C, I'm going to clear this so that you can write it up with me as I write it up, because this is the protocol of how to do it. So 4x minus 5y equals a negative 1. A negative 8x plus 10y equals a 4. Now if we put a line under these like we did for the first two, would anything cancel out? And the answer is no. So here's a case where we have to use a little judgment and critical thinking and analysis. If this 4x were a 8x, these would cancel out. So what I do is I put a bracket, and I'm going to multiply this equation. This is what I want you to show in your notes. You're going to multiply this equation by 2. Now once you do that, it's not the same equation anymore, but it's an equivalent equation. So this is how we do it. Put a little arrow. This is going to be 8x, multiplying it by 2. This will be a negative 10y, and this will be a 2. So this equation is equivalent to this equation, but in so multiplying it, I have developed that one of the letters will actually cancel out. Now I just write the new one right underneath it. Uh-oh, look what's happening here. Now you don't change the second equation, you just change the first one so that one of the terms will cancel out. But now when we put our line, we notice these cancel out and are 0. These cancel out and are 0. And this adds up to 6. And we get 0 equals 6. Is that a true statement? No. So what we have here are two equations that are parallel, so we're not going to have any solutions. So when we do what we need to do and we end up with an untrue statement, this is no solution. And that's the proof of it. Now as we do letter D, we've set it up here, over on the left, wherever you can find room. And now we're studying this, putting a line under here, nothing cancels out. So what do? Well, we have to think of multiplying this equation by something and this equation by something to get, let's say, the x's to cancel out. So if I multiplied this by 3, I would get a 60x here. What would I have to multiply this one by? 10. So I'm going to use my calculator and multiply through. So I actually didn't need a calculator. I could do those in my head. But you want to be accurate. You're going slowly enough to get correct results. Now you put your line. These cancel out and give you 0. This gives you a positive 45y. And then this gives you 180. Now when you divide both sides by 45, now sometimes you could write it out and sometimes you could do it mentally, that's fine. You get y equals 4. So you now have one of your members here, your y. Now here you want to use the original equation. That gives you less chance of making an error. And which one do you want to use? Well, let's use this first one. So 20x minus, now negative 15 times 4 is a negative 60 equals a negative 50. So I'm going to transpose this negative 60 to the other side. That gives me a positive 10. So I have 20x equals a positive 10. Divide both sides by 20. 10 over 20 is 1/2. So our x coordinate is 1/2, and that's what they have down below. So I've set up letter E, checking that I copied it correctly. Now again, nothing's going to cancel out, but I can modify these equations. And this is the judgment, critical analysis part. Now, these are both positive, these are both negative. So one of these, and I'll choose this, I'm going to multiply by a -2. And this one I'm just going to multiply by a 3. So this will become a -6x. This will be a positive 6x. So now let's do that. So again, they're not the same equations, but they are equivalent. So here this adds up to 0. This is a -2y equals a -4. Adding them up. Dividing both sides by a -2, I get y equals 2. So I have one of my ordered pair members, a 2. Now, I can use either of these equations, so I'll use the first one. 3x minus 5 times 2 equals a -1. So this is 3x minus 10 equals a -1. Transpose the -10 on this side becomes a positive 10. Minus 1 is a 9. Divide both sides by 3. I get x equals 3. And if we look down below, that is the solution. Now we're running 37 minutes for this lesson. We want to have time for questions. Let's just review this quickly. We're not going to do it all. But what technique would you use here to start us off? Well, I'd get rid of all my fractions by multiplying everything by 8. Here I'd multiply everything by 10. Every term. Then I wouldn't have to worry about fractions, and we would use this elimination system that we've already developed with a number of examples. So, keep in mind we are on section 5. There are 3 more lessons in this module that we should complete after 4 weeks. So then you take your test. The next module we're going to complete after 2 weeks. And if you pass modules 1 and 2, you have completed the first part of this course and will be registered for the next part. If not, you will be working on these and will take 2 semesters to complete the course. So again, trying to stay up to date is an important factor in getting this done in 1 semester. But some of this material is difficult, and it may take longer. Now, in our lecture sessions, we'll be doing 1 lesson as per the syllabus for modules 1 and 2. Once we start the later modules, we start doing 2 lessons in 1 day, sometimes. But again, this will give you the notes, the background, and you have these videos to review the process.